Hello, how are you? And welcome to our conceptual summary about mechanical wave. So, in dealing with mechanical wave, we will be looking into patterns. And these patterns will be utilized to determine the type of wave. So, for example, we have the traveling wave. Another one is standing, also known as stationary wave. So the mechanical wave and its patterns can be projected in what is called a sine graph. So a sine graph simply is divided into two semicircles. The first half of the circle is calculated with pi, and the completion of a circle is 2 pi. So basically, one sine wave is consisting of a one oscillation or one revolution. This time, we will be looking into the characteristic of a traveling wave. A traveling wave moves in one direction only. An example to this would be the oceanic wave. So an oceanic wave only has one direction, and that is going to the beach. On the contrary, our standing wave or stationary wave is just simply a movement of waves back and forth, for example in a string. Why? Because this is due to the boundaries. The boundaries that allows the wave to move back to the length of a string, for example. So in this case, if we are going to attach a string into the wall, and we will put a pulley on the end of the string, and then we will tie or hang a weight into the pulley, this will create what we know as tension. A tension is generated in both ends. When we are going to pluck the string, since there are two boundaries, it will vibrate and move back to the string. So this will create a stationary or a standing wave. So in a standing wave, we can calculate the velocity. But first, we have to identify the mass of the string. At the same time, the length of the string. We'll have to consider the value of mu, where mu is equal to the mass over the length, which will designate as the linear density. So velocity is calculated with the formula the square root of the tension over mu. Now going back to the standing wave, since they are moving back and forth due to the boundaries, this is causing what we call as interference. So interference is produced in the movement of a wave in a string that has boundaries at both ends. Now, the interference or the moving back or altering the wave of the original wave that was created in the string will produce what we call nodes and antinodes. The antinode is either the crest or the trough of the wave, while the node is at the minimum or at the equilibrium of our wave. Now we have to remember that there is no node in a traveling wave. So where can we find nodes? Well, nodes are found in strings that has boundaries at both ends, and at the same time in discs, drums, and other surfaces. For example, if there is a vibrating surface and you put a sand on it, then you will be able to see the different shapes of the nodes in a 2D surface. Nodes can also help us in calculating the frequency. Especially, this is very useful in the science of music, especially strings, because this frequency they are very specific to particular length. Particular length of the string. For example, a particular instrument that is producing a certain frequency with 1F, the value for 1F is equal to 1/2 lambda. And this 1/2 lambda is called the first harmonic or fundamental. For the second one, this is called the first overtone. This is given by the formula 2F is equal to lambda. And for the third harmonic, or also known as the second overtone, this is given by the formula 3F is equal to 3/2 times lambda. For the fourth harmonic, also known as the third overtone, this is given by the formula 4F is equal to 2 times the lambda. So that's it. Thank you very much.